This conference will now be recorded.
Okay, good morning team in this Databricks Data Engineering Master Program. This is 23rd session, already theoretical part we completed, right? We understand how Spark determines the number of partitions, how Spark can adjust the partitions. So to adjust the partition means either we can increase the partitions, we can decrease the partitions. So how it can be done? Using the repartition versus Coalesce. So repartition is used for increasing or decreasing the partitions, whereas Coalesce is used for only decreasing the partitions, right? So we have seen if it is increasing, we can directly go for the repartition, but if we want to decrease the partitions, we have repartition versus Coalesce. We have seen if the data is already even distribution, then we can go with the Coalesce for reducing the number of partitions. If the existing data is unevenly distributed, then we must have to use the repartition to reshuffle everything and create the new partition. So very quickly, I'm not going to explain each and everything, but high level we can quickly discuss. Okay, so yeah, so if you see, we will learn the importance of adopting the best partition strategies: Spark configuration, repartition versus Coalesce, repartition to increase, repartition to decrease, Coalesce to decrease the partitions we have seen. Okay, concludes the difference between Coalesce versus repartition. So there are two important things to consider the number of partitions is right sized partition and the right number of partitions. We have discussed right size means amount of data that we have in each partition is also important, and right number of partitions also important based on the number of cores in the cluster. Important like, so if you consider here, if you have two systems with two executors and each executor got a 4 cores, total here you can able to you can have a 8 partitions. If you have less than 8 partitions, then it is, you can consider it as a, it is basically, it can impact negatively, isn't it? Because if you have 8 people but you have only 4 chocolates, meaning if you have 8 developers who are working in a project but you don't have enough work, you have only 4 tasks to do, remaining 4 people idle. So that's how you must have to maintain a proper number of partitions to make sure all the cores get the task. So these things also we will discuss today hands on. Repartition, which is a wider transformation which do the event partitioning when you apply it. That's why when the source, the existing data is only unevenly distributed, then you can able to apply the repartition for the event partitioning. So you do the more resource consumption as there is a shuffling of the data. So that's why repartition is not much recommended. Whereas Coalesce, which do the less movement of the data, so less consumption of resources, it is good for the performance. Okay. So you can see, so if I apply rdd.repartition of 8, first it takes 6 partitions data, it shuffles it, just mix it. Then it is going to create 4 partitions here, 4 partitions here. Understood? So very similarly, when it goes for reducing the number of partitions from 6 to 4 using repartition, first it will merge everything, shuffles everything, then it creates here 2, here 2. Okay, this is how the repartition works. Whereas Coalesce, it just takes the all partitions as it is, extra partitions which combines with the other partitions. Here also P3 coming, P5 as it is coming and creating a P3, and whereas P4 plus P6 is merged and created the P4 partition. Okay, this is a less shuffling, so data movement is very less in the Coalesce. That's why this is recommended to use when you are reducing the number of partitions. We already discussed the repartition is used for increasing or decreasing the number of partitions, whereas Coalesce it is primarily used to decrease the number of partitions. Use cases When you need to shuffle data for better distribution or performance, let's say the existing data is unevenly distributed, I want to get an even distribution, you can apply repartition. So I want to reduce the number of partitions, ideally with very less shuffling, or you can say without shuffling. You can go for Coalesce. So repartition always do the full shuffling, whereas Coalesce could do it reduce the shuffling and do the partition, decreasing the partitions. Performance impact, more expensive due to full shuffle. It is more efficient when reducing the partitions. When to go for repartition? For even distribution of the data if you want in the output. When you want to increase the partitions, you can directly go for repartition. Coalesce you can go when you want to reduce the partitions and you want to avoid full shuffle of the data. Shuffle cost is high, it is low because it is doing very less shuffling. RDD syntax rdd.repartition. So here rdd.coalesce. Data from syntax df.repartition df.coalesce. Okay. So let's go and see this answer now. Okay. Let me just I'm just logging into cloudpandit@outlook.com. Come here. Okay. First, let's create the cluster now. Click on create cluster. 15.4 LTS. Click on create compute. After that, click on recent. Go to 23rd session. Let's do one thing. Let's import. Click on this. Okay, let's do one thing. I don't know why it is coming like this. Maybe let me log in with my Gmail account one. Is it because of the so many notebooks, the size of that particular storage got full or what? We don't know. Let's see now. I'm trying to log in into the other one. User is not a member of this account, that is saying okay. Let me see. Okay, here it is logged in, right? Just I'll click on compute, click on create compute. Let me put it as a 15.4 LTS. Click on this. After that, uh, click on workspace, click on just here input. 23rd, right? Yeah. So I think that's the problem with that Databricks workspace. I was thinking network issue on the day. Okay, let it come. The cluster, let it come. Okay, fine. Just wait until the cluster is availability. It takes few minutes to come up. So let's close everything. It is not recording anymore. Yeah. So remember here, SC is nothing but a Spark context team. Default parallelism means what is the default number of partitions it is going to create on the local data, we will see. After that, I am using, see, this is the default configuration. I am trying to get it. Now, SC is nothing but a Spark context. On top of that, I am creating a parallelize. So to this parallelize, I am passing a values from range of 100 means it generates a values from 0 to 99. 0, 1, 2, 3 and so on up to 99. These 99 values which creates a RDD object. But it's a Spark, right? 0 to 99 values are divided into how many chunks. Each chunk is called a partition, right? Now I want to know RDD is divided this 0 to 99 values into how many partitions. In order to understand the number of partitions in this RDD, you need to say RDD dot get number of partitions, get the number of partitions. Okay, so you got the number of partitions. Okay, maybe it will say 8 or 4 or 2 or whatever. Now the thing is, let's imagine we have 8 partitions. In each partition, what numbers we have between 0 to 99, data is divided across 8 partitions, right? Understood, Tim? 0 to 99 uh, numbers are divided into 8 groups. Each group is nothing but one partition. Let's imagine now I want to understand what numbers are there in the first partition, what numbers are there in the second partition, what numbers are there in the third partition. In order to understand that, on the RDD you can say gloom that collect. So from each partition, whatever data is there, can you collect and show me? Collect is a action. Gloom is a transformation. Paralyze is a transformation. Okay. RDD.gloom. So we are asking the number of records that we have in each partition. Can you collect it? After that, count equal to 1. So rdd.gloom.collect. Now we are just trying to print each partition. Okay, each partition data count equal to 1. So first partition data. Okay, see, one count equal to 1, right? Meaning 1 colon first partition data it will display. After that I am increasing the count to 2. So next to 2 colon second partition data it will print. Next I am increasing the count to 3. Third partition data I'll print it, because gloom will give first partition, second partition, third partition data, right? To make you understand that, I am just using a one count variable to increase. When it is printing the first partition data, it count will be 1. When it is printing second partition data, count will be 2, and so on. Understood? Fine. Now let's try to execute this. Still it is setting up one node. Okay, meanwhile we will discuss the things. Now I am trying to understand default partition set on the external data. Let's say if you are reading some file from data lake or blah or whatever. So based on the data, how it can able to divide. If you just execute this, it will say the default number of bytes. So that you need to divide it into the 1024 bytes into 1024 again. Um, I think in the kilobytes, right? So first you need to divide with the kilobytes, then again if you just divide this bytes with the 1024, it will first convert into KB. Again if you divide it with 1024, it will convert into the MB. Okay, so now we will get to know the default size of each partition which is set. Okay, after that we will try to read the data and let's see. Okay, it is starting the Spark. Okay, you can see the default number of partitions, it's set it to 8. Now I'm just trying to create a range of 100 values. Now it is saying the default also it is created 8 partitions, correct? See, this is RDD is having how many partitions? It is saying 8. But now what data we have in this RDD? 0 to 99. Now I want to understand how this 0 to 99 is divided across the 8 partitions. Let's see. See here, 0 to 11 is the first partition, 12 to 24 is the second partition, 25 to 36 third partition, 37 to 49 I think fourth partition, this is the fifth partition, this is the sixth partition, this is the seventh partition, this is the eighth partition. Everybody understood it? So these are the 8 partitions what we have. These are the total 8 partitions what we have. Tim. Understood? Now if you just execute this code, you can see first partition data is this, second partition data is this, third partition data, fourth partition, fifth, sixth, seventh, eighth. Just to show you, I have written. It is not required. Okay, each partition data I want to show you from 0 to 99 values are divided like this. Understood? Okay, so this is default number of partitions set on the local data. Now let's say if you are reading external data, let's see. So this is the bytes B, you can see, right? Same thing I put here. First I am dividing with 1024 to convert into the KB, next 1024 to convert into the MB. So if you see, the default size of each partition should be 128 MB, meaning now if you are reading a file which is, if the file is very huge, if the file is 250 MB, okay, then it divides into the 2 partitions. But the file that you have is also splittable. Splittable means if that particular file is created by some automated process or something, it can't able to split it. Okay, so I'll show you what it means is. Now what we will do, firstly I'm just trying to check if at all credit data folder is there in the file store / tables. If at all it is there, you can remove it. False, meaning it is not there. Now I'm just trying to create a folder called credit data folder. Yes, it is saying yes, it is created. Now I'm saying file store / table / credit data. I'm just listing down what is there under credit data. It is saying nothing is there. Okay, nothing is there. So now I'll go and upload some data in this. Okay, now I'll go and upload some data in this. Now what you can do, right click on this, click on duplicate of this. Very careful, observe from now onwards. Click on catalog, click on create table, just click on drop files to upload, click download. After not download, under 2024 syllabus Databricks datasets 23rd session, I'm just uploading all the files. Click OK. I'm just removing the employee.csv, daily, monthly, weekly. These 3 files I just uploaded. Okay, I just uploaded these credit files. Okay, now let's try to read. Can you guess it and tell me how many partitions it will create from your existing knowledge? Can you guess it and tell me how many partitions it will create? Tell me, team. Why you are not able to tell that?
8.
Okay. Anything is fine. You just guess it and give me
20,
answer.
24.
Whether okay. So first of all, you need to understand here. So the default number of partitions set is 8 on the local data, but it is external data. I'm reading from some other location. So based on that, you need to understand, if the file size is 128 MB, it creates only one partition. If a particular file size is 250 MB, then it creates a two partitions. If the same file size is 400 MB, it creates a three partitions. Three or four. If it is a 400 MB, I think it creates a four partitions, because 128 MB, 128 MB, 128 MB, and after that I think you will have some 16 MB, whatever is left. With that, it creates a new fourth partition. Understood? Each partition, if the file is having 128 MB, it just creates one partition. If the file is 256 MB, it creates a two partition. Like that, multiples of 128, each 128, it creates a one file. Okay, but now let's imagine, if you have a two files, if you have a two files, each file size is 60 MB, then how many partitions it creates? If I have a two files with the 60 MB, how many partitions it create? Each file size
One
is 60 MB. Hmm?
One
one partition.
Okay, yeah, this is what you should understand. So it consider 128 MB within the same file. It will not merge two files. That's why if you have a two files, it creates a minimum of two partitions. But if this file size is 250 MB and this file size is 60 MB, now it creates only one partition with this, but with this it creates a two, because it is more than 128 MB. It divide 128 MB and 122 MB, and it creates a two partitions. Total it will become a three partitions. Are you getting? Are you getting, team? If you have a
Malaya, could you please repeat, because it's confusing?
yes, I'm repeating, just hold. So if you have a single file with 60 MB, then it creates a one partition. If you have a single file with the 120 MB, it creates still with the one partition. If the single file which you have with the 200 MB, then it creates how many partitions? It creates a two partition, because 128 MB is the one partition. A remaining data, whatever is there, approximately 72 MB. So with that, it creates another partition. Okay. Now with same example, if you consider first case one, two files are a 60 MB. How many partitions it creates? So for
one
each
partition.
file,
Two.
for each file, one partition. So total two partitions. Okay. Let's say case number two. First file is 200 MB. So we know for this file directly two partitions it creates. For next to file, it's a 60 MB. For this it creates a one. So two here, 1 here, total three partitions it creates. Understood? Now we know it is 128 MB, but the existing data that we have is this data, right? Monthly, daily, weekly. We want to understand. We want to understand, before we read, we want to understand, right? What is the size of this? You can see. Oh, it is not. Oh shit! I uploaded directly under file store / tables. I think we need to upload under credit data folder. Okay. Now let's click on this. Upload these three files. So now you see it is uploaded under credit data folder. Correct. Now come here. Let's execute the files. So the file size, if you see, 11732. Okay, this is, it is the bytes, 11,732 bytes, 54,000 bytes, 43,000 bytes. But what is the default number of bytes? It is very huge number, you can see here. Correct? Correct, Tim? 134,217,728 bytes. Now we know that all the file size is less than this. So That's why it can create only one partition for each file, isn't it? Only one partition for each file it will create, because if you consider a single file, this file size is less than the default number of bytes for partition. So that's why this particular file creates a only one partition. Again, this file's size is also less than the default partition size, correct? So that's why this also creates only one, this also creates one. Now let's try to understand spark.read.cs. So I'm reading the all files from this particular folder. I'm trying to get the number of partitions. How many partitions it is created? 3, correct? Now what we are doing, max partition size, we have set it like by default it was very huge number, right? 134 million. But now I am changing the default value to 15,000 bytes. Okay, 15,000 bytes. 15,000 bytes, if you convert into KB, it is approximately 14.6 KB, but no need to convert into KBs and all. Now you can see 15,000 bytes is the now default size. Now is it less than 15,000 or higher than the 15,000?
Less. First one.
Less. So how many partitions will create from this file?
One.
Only one.
Okay, one. Only one. Very good. How many partitions will create from this?
4.
From this file?
4.
4.
3.
Correct. How many partitions create from here? 3. So 3, 4. This is 1. So total number of partitions are now
8.
how many? 8. Right? Let's see. Really creating 8 partitions or not? You can set it. You can see here. Is it created 8 partitions? Now let's say I'm changing the size to 30,000 bytes. If you make it as a 30,000 byte is the default partition size, if you set it, so here it creates only one partition. Yes. Here it creates
2.
2. Here it creates 2. So total number of partitions should be 5, isn't it? Now let's see. Is it creating 5? Yes. You can see 5 partitions it is created. Understood? Now you understood how we can able to set the number of partitions. Okay. So default at the time of reading 128 MB is the default partition size. Okay, you can keep it as it is, but if you really wanted to increase the size of partition, or if you want to decrease the size of partition, you can just do that this way. Understood? But now let's say if you want to adjust the number of partitions. Okay, if you want to adjust the number of partitions, let's see. So sc dot parallelize. Okay, it creates rdd dot coalesce. So I'm just trying to show you the documentation. Coalesce. This is on the rdd team. Coalesce function on rdd, how it will work is, so number of partitions you can give, it can decrease it. But you can also, don't confuse, we won't use this, but I am trying to tell you all possible ways, because if I'm not telling this, you will always think that Coalesce is used only for decreasing the partitions. But you go and see anywhere, everybody will tell that Coalesce is only for decreasing the partitions. Okay? Even if you go here and Google it, difference between Coalesce versus repartition. Repartition can be used to increase or decrease number of partition, but involves heavy data shuffling. On the other hand, Coalesce can be used only to decrease the number of partitions. Okay, you go and read wherever, it says same. Okay, so difference between Coalesce uses existing partitions to minimize the amount of data that it shuffles. Repartitions creates a new partition, does a full shuffle. Okay, so they are also saying same thing, right? Coalesce may run faster than repartition but unequal sized and all. But ultimately, you can see it's recommended to use while reducing the number of partitions. While increasing the number of partitions, because it involves the shuffling of all the data. But ultimately, what they are saying is, they are saying Coalesce is used only for decreasing, but that is not the true. You can also use the Coalesce to increase the number of partitions only on the RDD. If you are creating RDD object, you can also use Coalesce to increase the partitions by making the shuffle equal to true. If you make shuffling of the data equal to true, then it will do the full shuffling of the data. It can increase the partitions as well. Understood? Next. So same data frame dot Coalesce. If you say, see, this Coalesce is not having any shuffle parameter, because here Coalesce you can't able to use for increasing the partitions in the data frames. In the data frames, Coalesce is used only for decreasing the partitions. Remember, Coalesce is used for reducing the partition, whereas RDD is for increasing the partitions or reducing the partition. But Coalesce on RDD is also used to increase the partitions. That is the extra point you should note down. Coalesce can be used to increase the partitions only on RDD. Understood? Next, RD.repartition. So repartition, just it is, if you give this, if you give more number, it can increase. If you give less number, it will decrease. That's it. Even repartition on the data frame is also same. Repartition on the data frame is also same tip. See, you just have to give the number of partitions, but partition can be done it on the particular column also in the data frame. Repartition in the data frame can be done on a particular column as well, because it is a structured data, right? You will have a proper columns and all. Based on particular column, if you want repartition, that is also possible. Now, sc.parallelize range of 100, r1.get number of partitions. So how many partitions it creates by default? Tell me. 8. Now, no, not 8. I want customized partitions. Then you can say sc.parallelize range of 100 comma 6, meaning you are saying, hey, don't create default number of partitions, please create only 6 partitions. I'm saying yes, it can create only 6 partitions. Okay, so if you just, you can see, right, range of 100 means 100 comma 6 means 6 it is creating. But if you give 4, it can create 4. If you give 10, it can create 10. Okay, remember, again I am taking the default number of partitions is 8. Now those 8 original data I'm just displaying. See, these are the 8 partitions. Now I'm using r1. Okay, r1 dot Coalesce of 4. Coalesce of 4 means what, team? Are we reducing partitions or are we increasing the partitions?
Reducing.
Reducing. Okay, very carefully observe. 0 to 24 is here, 25 to 49 is here, 50 to 74 is here, 75 to 99 is here, because it is in a proper order. What is happened? So you made 8 partitions to 4, then simply it combine first 2, next 2, next 2, next 2. It creates a combination of this is 1, 1, 1, 1. So it creates a 4 partitions. All of you clear? But if we come
Yes.
down, now after that R2 we are seeing gloom, right? Now again I'm trying to show you R1. R1 is the original data frame. Okay, now if I am using repartition of 4, okay, please try to understand. I created R1, which is a default partitions is 8. Now I have used Coalesce to reduce it to 4. Okay, now same R1 I am using to reduce it into 4 by using the repartition. Are you getting? So R1 will not change. 8 you reduce to 4 using Coalesce created a R2. Correct? Understood, Tim? But now same R1 result I am using to reduce it to 4 partitions using repartition, and I creates a R3. You can see here R3 is creating. Now let's try to understand, if you just reduce the partitions to 4 using the repartition, you see it is shuffling, right? So that's why we don't know 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 47, 48, 49, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84. Meaning, so numbers are not in a continuous, right? So if you compare from year to year, 25 to 34, 25 to 34 is from the third partition, 47 to 49 is from the fourth partition, 60 and 61 is from the fifth partition, 62 to 70, 71 is for the next partition. Next, 77, 78, 79, 80, 84. These all things, meaning from all these 5 partitions it is mixed to create a single partition. Again, next partition 0 to 9, 0 to 9 is mixed. Again 12, 13, 14, 15 is 15, 16, 17, 18, 19, 20, 21 is mixed. Again 35, 36 is mixed. 72, 73, 74 is mixed. 85, 86 is mixed. Understood? It is basically shuffling, meaning all partitions, mixed data we are getting in the next partition output. That's why I said repartition shuffles completely, whereas Coalesce will not shuffle. It just keep the data as it is. It will try to reduce the shuffling as much as it can by moving only extra partitions. Are you able to understand very clearly the repartition and Coalesce when we reduce the number of partitions, how it will behave? All of you understood or not?
Malay one doubt.
Hmm.
Even the Coalesce statement will do very less shuffling.
Hmm.
Can't we call it as white transformation?
That is
Because I
also
know
white
I
transformation only.
yeah, yeah,
It is
yeah.
also
So
white transformation only, but
uh,
we are only saying it is a efficient as it reduce the shuffling amount of data that it is going to shuffle.
okay.
Any other doubts? Now, if you see original RDD, how many partitions we have, like those partition data I am displaying, Coalesce 4. After I reduce it to 4, those I am displaying. Repartition of 4, after that I am displaying the 4 partitions. Now you can see all the data at here. These are the total 8 partitions. Coalesce of 4 is this. Repartition of 4 is this. Now if you want to compare, you can see this is in a proper sequence, it is chunked. Okay. Here also just first 2 partition merged, next 2 partition merged, next 2 partition merged, next 2 partitions merged, like this. But here the problem is it is just shuffled the data from mixed partitions data we have here, mixed partition data we have here, mixed partition data we have. Any questions still here? Please let me know, Tim, before we move on to further. Okay. Now I am creating R4. R4 is having only 4 partitions. Let's see what are those R4. So 0 to 24, 25 to 49, 50 to 74, 75 to 99. So R4 dot Coalesce of 6, if you give, try to increase, it will throw error. It is not going to throw error, but it will not increase the partitions to 6. See here, R5 is there, right? Now if you say R5, it still says 4 only. See, 25, 25 to 49, 50 to 74, 75 to 99. So 4 partitions as it is, it will be there. Understood? Now, can't we really increase it? We can increase it. I'll show you how we can increase it using Coalesce. I'll tell you, okay? R4.glow off collect, you can see 4, R4 is still 4 only. Now same R4 I'm using to increase the partitions to 6 using the repartition. Now let's see R6 gloom.collect whether we have 6 partitions or not. You see, yes, this is 1, 2, 3, 4, 5, 6. Understood? Now let's try to see R4 is having a 4 partitions. 1, 2, 3 and 4. After applying Coalesce of 6, it will not make it as a 6, it will be still 4 only, you can see, because Coalesce will not allow you to increase the partitions until unless you have used the all flags. See here 4 only in the Coalesce, but repartition made it as 6. 1, next this is 2, next this is 3, this is 4, next this is 5, this one is 6. Understood? Now if you come down, R4 Coalesce of 6 gloom.collect, if you use default like this, it will not increase. But if you say R4.coalesce of 6 true means do the full shuffle and create 6 partitions. Now you see it is very similar to repartition. Now it created a 6 partitions. You can see 2, 3, 4, 5 and 6. Understood? You just have to use this particular flag. This is all on the RDD. Now let's understand repartition versus Coalesce with data frames. Okay. Now employee data folder I created. Let me upload employee data under employee data folder. Just to click on this. Click on employee data folder. Let's browse and upload employee data. Come here. Okay. Now let's try to read that file and create a number of partitions. So let's see, it is just creating a single partition. Okay. Now we want to understand the partition ID. If you have only one partition, it creates only one ID, but this we need to import it. So this is the one function that you need to import it here. So just it add a new column called partition number column. It will add, see, partition number, which is 0, because only you have a one partition, so that's why that partition number is 0. Okay. Now this data frame, this original data frame which has only one partition, now I am increasing it to 3 partitions. Now I am trying to add a partition number to each of the data, because gloom and all will not be there here. To understand the data, see, this is all in the 0th partition, first partition, this is in the second partition, this is in the third partition. So you can understand that repartition of 3 when I have used, it is increasing the partitions, correct? Now, so this is df, you have a df. I am, so basically if you look at here, in this each partition, the mixed departments are there, right? Mixed departments are there, right? 10 is there, 20 is there, 30 is there in the first partition. Similarly in the next partition also you have a mixed departments, correct? In the next partition also you have a mixed departments. How I am saying this is the next partition, you can see number 2, this is the third partition. Mixed departments are there, 10, 20, 30 and all, right? But now what I want to, the original data frame you take, increase the partition to 3, but when you are dividing into 3 partition, make sure similar department should be there in a same partition. That is what the column indicates. Same departments. Now you see all these departments. So all these 30 departments are available under a first partition. Next. So 80 is available under a second partition. Okay, because there is we have only 3 partitions, right? So all other remaining departments put it into the, so 10 20 which is remaining, so all the 10 20 departments put it into the second partition. So that's how it will try to keep all the same departments under a same department under a same partition. Understood? Next, this is the data frame 1 which is having a 3 partitions, correct? df1 is having how many partitions? 3. Now I am taking df1 dot coalesce of 2. I am trying to reduce it to 2 with the column is partition number. Whether it will reduce or not, you can see 0 0 0 here, 0 0 0, and this is all 1 1 1, meaning all these are reduced or not? Yes, all this 30th department is into first group, all remaining data into the second. Okay, so Coalesce is reducing the partitions even in the data frame. So this particular data frame, you can just group by partition number to count how many records are there in each of this partition. You can get it. So from 0th partition we have 12 records, in first partition we have 18 records. Understood, team? That's all, team. We have shown how to increase the partitions, how to decrease the partitions, correct? And then we also have discussed how you can increase the partitions using the Coalesce shuffle partition flag. And while increasing the partitions based on particular column, if you want to increase the partitions, that also we discussed repartition of 3 and based on department number. Okay, yeah, that's all from my end. If you have any questions, please let me know, team.
Malaya, uh,
Mm.
can a null column can be given as part of partition ID?
If you give the null, that is not the good choice, right? If you give null, what happens? It can't able to divide the data.
No,
It can't able to divide the data.
do we have any thumb rule like only this particular these kind of columns only we have to give as partition ID column?
Okay, so for example, you have a date column. Generally, if you have a date, right? So each day data, I want to keep it into the proper partition, particular partition. Let's say 1 month data you are processing, right? So what you want? You want month, day of the month. Day of the month means first, second, third, and so on up to 30 days you have. When you are creating the partitions, all the like particular day data, I want to keep it into the same partition. Are you getting?
Yeah, while
Okay.
processing the data day
Yeah.
wise, yeah.
So similar to that, maybe you have a location ID or product ID. So similar product category ID, because all the similar category of products that I want to keep it into the same partition. So those all are the use like examples that you can consider. But null, we won't take it because the purpose of the partitioning will not serve if you do the nulls.
Okay, noted. Thanks.
Any other questions?
Yes, Malaya. So, as you said, say for example, we have 128 MB of file, maybe the default size, and we have only 60 MB of file, and which is loaded to, which has one partition,
Hmm.
and remaining 160 MB, it will go unused for forever, or it will be filled somewhere. In near future, or how it would be. The 60 MB will be unused.
No, come again your entire question.
Say
What is
for
it?
example, we have set the default uh, file
Okay,
size is
128
128
MB.
MB, and
Okay,
we have a file with MB of 60 MB, and
okay.
it goes to that file. It creates one partition. That 60
Mm.
MB of size will be unused for that particular file. So
No,
it
no,
will
no.
be
What
filled
is
with any.
unused? Hold on. What is unused? Here,
I mean,
partition size is small, so your data will be processed very quickly. See, you
okay,
need to understand the cores. So, for example, in this compute you have, which is having a, for example, two cores. Okay. Now, if you have a 60 MB, what is the problem? The problem is you have two tasks it can take, but 60 MB creates only one partition, meaning only one core you are using. Now this 60
okay,
MB also I want to decrease, like I want to create a two partition. That's why I'll say the default size it to 30 MB, so that it can create a two partitions. I can submit a two partitions on the two cores, both run in parallel.
got it, got it. Okay, the memory is not completely utilized. Okay, it's based on the MB and the partitions. Got it. I thought like the memory can be allocated for that file
No,
itself.
no, no, no.
Oh, got it, got it.
Yeah. It takes some time because it is not something direct you can able to understand. You need to go through the recording multiple times. Slowly, when you practice, only you will come to know in depth. Okay, confusions will be there. Go through, and if you have any questions at any time, I can take and I can answer you. Don't worry, but you need to put some effort from your end also. Okay. So tomorrow we will also discuss cache versus persist, those things also, how it will work in the back end. Okay. Any questions for today, team? Final call team. Any questions? Okay, fine. If no questions, thank you all.